Mercury is one of the most forgotten planets in the solar system because it is so grey and cratered. But there is in fact so much more to discover about this tiny planet. Closest planet to the Sun may seem like a very boring planet, but it is in fact so much more than what you see as the barren planet. Mercury has been known since the ancient times. They noticed a small star moving very, very close to the Sun, and the ancient Romans named it after the winged messenger Mercury because of its fast motion through the sky. So first of all, let's talk about Mercury's orbit. Mercury orbits in a strange elliptical orbit that takes it as close as 46 million kilometers from the Sun, but as far away as 70 million kilometers. Those distances average out at about 58 million kilometers. It's the most eccentric orbit in the solar system of any planet, and it takes about 88 days for it to complete one orbit, which is about 3 months on Earth. An unusual thing about Mercury is that it has a very strange rotation period. It has a sidereal day, which is the time to rotate once, of about 59 days. But because this is about 2/3 roughly of its year length, that means that it has a very strange spin-orbit resonance of 3 to 2. And so that means a day in terms of the Sun rising and then setting can be as much as 176 Earth days. And that means that its day is twice as long as its year. Mercury has almost no atmosphere, and so it cannot keep in the heat that it receives from the Sun on its night side. So in the daytime, the planet can reach over 400 degrees Celsius, but at night it drops to a very chilly minus 180 degrees Celsius. So even though it's the closest planet to the Sun, its temperatures can drop as low as those in the outer solar system. As mentioned before, it's the smallest planet in the solar system by far at 4,880 kilometers, but for its size it actually has quite a high mass, which results in a very high density of 5.43 grams per centimeter cubed. Analysis with the Messenger spacecraft that arrived at Mercury in 2011 revealed that Mercury has an enormous core, and that would explain why the planet is so dense. Its core extends to 85% of the planet's radius, which is way bigger than any planet normally would have. But more evidence was gathered by the Messenger spacecraft while it was there. It detected volatile elements on the surface of Mercury. Volatile elements are elements that boil away easily. Sort of, you're talking like your sodium, your potassium, your sulfur. Those elements will boil away at something like 100-ish degrees, possibly higher. But how is this possible when Mercury, as I said, is 400 degrees Celsius in the daytime? Shouldn't those elements be boiled away already? If the planet formed at this distance from the Sun, these volatile elements would not be present on the surface of Mercury. The amounts of these elements are small, but they are significant enough to raise big questions about the details of Mercury's formation. Did it form where we see it today, or did it form somewhere else? Because of the presence of these volatile elements, we think that Mercury was formed about 170 million kilometers further out than we see it today. That would mean that it formed near where Mars is today. The unusual size of Mercury's core could be explained by a massive impact early in the planet's history. Perhaps when Mercury first formed, it was a lot bigger, but then this other planet came and knocked it into where we see it today and shed most of the outer layers of its crust off, and that's why we see the massive core today. But this is a slight problem, because if there is any collision between massive bodies, then it will heat up Mercury and whatever collided with it, and that would mean the volatiles would be boiled away, and so the precise nature of Mercury's formation is still a great mystery. As stated before, Mercury has an incredibly battered and old surface. Clearly not much has happened in its history for billions and billions of years. It's a dead world, quite frankly. But craters are not the only feature that we see on this planet. Messenger took pictures of these strange ridges of rock that almost look like the planet has been shrinking, and so the rock has been crumpled on top of each other into these ridges. And that would make a lot of sense, because if Mercury's not been active for billions and billions of years, it would have cooled, and this cooling process would indeed shrink the planet, because that's how thermodynamics works. But there is a massive crater that is on Mercury's surface that is one of the largest impact craters in the whole solar system, and it's called the Caloris Basin. It is the largest crater on Mercury and one of the largest in the solar system. The object that must have hit here would have been huge. The ripples that we see across Mercury today are striking. On the direct opposite side of where the Caloris Basin is, we see this junky and weird terrain on the direct opposite side called the antipodal point. And so how that works is that the shock waves that were caused by the massive impact that caused Caloris Basin would have travelled all the way around the planet and met on this antipodal point, and would have jumbled up the terrain into very strange shapes. Another thing about Mercury is that its axial tilt is pretty much 0 degrees. That means it points nearly straight up in comparison to its orbit around the Sun. And so that means that in the shadows of craters in the North Pole, we have found permanent water ice. Messenger, the NASA spacecraft, found water in the permanently shadowed regions of the North Pole, because there will be permanently shadowed regions if Mercury is almost perfectly straight up. You may notice in this sped up footage on Space Engine that the daytime side of Mercury appears to pause and then move around again as the planet rotates. That is a consequence of Mercury's 3-2 spin orbit resonance. A very surprised discovery about Mercury is that it has its own magnetic field, which is a huge surprise because of the size and distance from the Sun that Mercury is. It shouldn't really be possible for Mercury to hold on to such a magnetosphere. Earth has its own magnetosphere because it is much larger than Mercury and is further away from the Sun, so it's able to hold on to its magnetosphere. But this is a great mystery. Why does Mercury have this magnetosphere? It's not a strong magnetic field by any means at all, but it is still fascinating to think that it has one, and is the smallest object in the solar system to possess one. And it's especially surprising that when you consider Venus and Mars do not have any intrinsic magnetic field within them, but Mercury does. And that's a mystery we're just going to have to live with until we solve it. All this mystery and speculation will hopefully be answered by an upcoming mission that is on the way to Mercury right as we speak. It is called Bepi Colombo, and it is a European mission, and it is a collaboration also with Japan. It's basically two spacecraft that are currently both attached to each other. They will separate once they reach Mercury and go into orbit around Mercury, and they will study these mysteries. How did Mercury form? Why are there these volatile substances on its surface? Why does it have its own magnetic field but Venus and Mars do not? Bepi Colombo launched in October 2018 and has completed one flyby of Earth. It's completed 2 flybys of Venus and 3 flybys of Mercury. There's 3 more flybys of Mercury until it can enter orbit around Mercury. It is very, very, very difficult to reach Mercury with a spacecraft because it is so close to the Sun. You have to gain so much energy with flybys, basically called gravity assists. They either increase or decrease your energy depending on where you want to go. You cannot go directly to Mercury. It is going too fast and is too close to the sun for the spacecraft to properly be able to slow itself down to enter orbit. Essentially, if you try to go direct, then you would end up just falling straight towards the sun. You would not be able to slow yourself down. If you could, it would require enormous amounts of fuel, so an indirect route is favoured over a direct route. This is what Messenger did from 2004 to 2011. This is what Bepi Colombo has currently been doing since 2018 to now. As I said, there are 3 more flybys of Mercury to go before it then enters orbit, and it should be December 2025 that we can finally start unlocking the secrets of this mysterious planet. Thank you everyone so much for watching this video. I hope you all enjoyed. This was my first video on this channel. I hope to do many more videos on especially the planets. I certainly enjoyed making this one, and I hope to see you in the next episode. Goodbye guys. But it is not. It is. But it is clear. It is. I can't talk today. This resonance creates a strange effect in the sky, as if the sun stops. Entirely a consequence of the very slow rotation and comparatively. This is a consequence of the short orbit and the... Oh my god! Of course, being the smallest planet in the solar system,